Thanks so much, Grant. And hey, everyone, it's Daniel Litwin here, the voice of B2B, excited to bring you the biggest B2B stories in technology from the month of May on MarketScale.com. First up, a report on new cryptocurrency regulation. In March, the EU passed a new bill, the Markets in Crypto Assets Bill, or MiCA, that aimed to set financial frameworks for expanding the industry in all 27 member states. One of the most debated and infamous parts of that bill, though, was the language around crypto mining and its impact on the environment, which almost banned Bitcoin mining in the whole European region. Legislators argued that crypto mining was having an oversized impact on climate goals and needed to be reined in. Crypto professionals argued the EU was going too far and would tank the industry. So how should the industry engage with this important European bill? I did a full report on it. Let's break it down. First, we're going to break down the regulatory impact of MiCA. So according to the Cambridge Bitcoin Electricity Consumption Index and their most recent data set, about 11.06% of crypto mining operations happen within the EU. And even that number is a bit inflated. So this regulation is shaping up to affect a small piece of the global crypto mining ecosystem when you think about it holistically. But will MiCA make it an even smaller footprint and push away the crypto community? Not necessarily. More regulation could actually mean more growth.
Empirically, most countries who adopt some form of neutral or favorable regulation have seen explosions in new markets, talent, and overall opportunities.
One study of the European Economic Area found that stricter regulation around securities trading, which I guess you could call a sister financial sector to cryptocurrencies, and more specifically, harsher penalties for insider trading and increased consumer protections, actually motivated households to increase their equity ownership between about 5% and 12%. So in this case, regulation in the financial sector built trust. We also have crypto examples of this same trend in action. In India, an increasingly growing hub for the crypto market, we saw legislators pass an 18% goods and services tax on cryptocurrency trading in early 2021. Now, throughout that year, India's crypto market grew 641% in 2021. And India's largest cryptocurrency exchange platform, WazirX, posted a 1,735% year-on-year growth in trading volume. So again, regulation here, taxation, didn't deter growth. It could be argued it was neutral, if not encouraging, to the industry. So let's at least have some cautious optimism around MiCA. Next, let's break down Bitcoin's environmental footprint. Now, a majority of coins on the market today, including Bitcoin, operate under a proof-of-work mining model. Bitcoin's hash rate alone has been steadily rising even after it lost a major mining player, China, in July. Is that amount of mining, though, destructive enough to the environment to warrant a mass transition away from proof of work?
So a single cryptocurrency today might use more electricity than all of Ireland. That's crazy.
Bitcoin's energy spend often gets framed up in a country comparison context. When an industry outsider hears Bitcoin mining uses more electricity than Ukraine or EU members Sweden and Netherlands, it can feel like an obscene amount of energy for a still emergent market. And yes, it is a lot of energy, but a little more context helps weigh a realistic action plan for bringing down that carbon footprint.
I hope to see miners explore renewable sources, as this will give further credence and legitimacy to the industry as a whole. However, I would say in current form, proof of work mining energy consumption is comparatively low to most other industries.
Analysis from the Bitcoin Mining Council reflects this, showing Bitcoin's energy spend is minuscule compared to mining for gold, let's say, the finance and insurance industry globally, or the global construction industry. And this line of thinking appears to be where the EU landed with MiCA, including some final language that calls out how environmental legislation around crypto mining should, quote, work towards a holistic legislative approach, which is better placed to address such issues in a horizontal manner.
Shouldn't we also take proactive measures and steps and evolve into business practices that help sustainability and a greener planet? We should. So I don't think we should wait for regulation. I think we should self-regulate ourselves, and we should bring in practices that help reduce the carbon footprint and also contribute towards extracting the carbon from the atmosphere.
And it seems that self-regulation is already on the mind as the share of spent Bitcoin energy sourced from renewables is growing.
There are estimates that indicate that over 40 to 70% of all Bitcoin mining is already being run on renewable energy.
More Bitcoin Mining Council data reflects this as well. Take this with a grain of salt, but it estimates nearly 59% of the global Bitcoin network is already powered by renewable energies. Mining technology is also improving its processes with the climate in mind.
Companies that are already trying to make proof of work more energy efficient include Intel releasing a Gen 2 mining chip that promises to improve upon Gen 1 mining technology.
Any new cryptocurrencies brought into the European market will need to prove that they're climate conscious. Mika calls out that an independent assessment of likely energy consumption will be mandated for new crypto assets. So it's in miners' best interest to start weighing some ways, whether it's better tech, cleaner energy sources, or different consensus mechanisms to align with the EU's goals. To read my full written report as well as engage with some more interviews from key thought leaders in the industry, make sure that you're visiting the software and technology vertical on MarketScale.com. Next up, it wasn't so long ago that cloud computing was the trending topic for the growth of the wireless industry, and new technology implementations led to rapid migration of the cloud from on-premises data centers to cloud servers. However, we're seeing the pendulum swing in the other direction now as edge computing is surging in popularity. Why is this happening, and how should you evaluate which option is best for you? Well, find out in this short-form documentary from MarketScale.
Why is it beneficial? Your latency, bandwidth, security, privacy, and autonomy.
Edge. The outside limit of an object, area, or surface, place or part farthest away from the center. When we think of the word edge, you think of the end of an object or place. Where the tree line breaks at the end of a forest, the blade of a knife, or the cliff of a mountain. It's not usually the case where the end actually means the start, but that's exactly what edge computing is.
Cloud computing made everyone's life easier. If you go back before the cloud and you needed to deploy an application, as a customer, you had to go buy a server, install an operating system, you had to install a database, and then only then could you install that application. And of course, there would all be these dependencies as you installed it that you'd have to solve for. It was a mess. With the cloud, you could just push a button and you have the enterprise application you want. You can start using it already without having to worry about databases and operating systems and servers and depreciation and all that. And as a software vendor, it was also, cloud is also a great boon because you now can deploy into an environment that you control. In the past, you supported something that you didn't have a control of. And if something went wrong, it was almost like you had one arm tied behind your back. Plus, you had no visibility in how your customer was using it. You had to encourage your customer to keep up to date with new versions, which some wouldn't, and then you were stuck with supporting multiple versions. Cloud made everyone's life easier, both the customer and the software vendor. But we came to realize that not everything can run in the cloud.
According to a Gartner forecast study, over a third of organizations consider cloud computing as one of their top 3 investment priorities. However, cloud computing isn't without its limitations. It requires significant bandwidth and struggles with latency, making it challenging to use with sophisticated industrial IoT applications, which require real-time computation. Enter edge computing.
We can really start to bring time to value on data that is generated at the edge. What this means is as data is created right then and there, if you have the facilities to either normalize or or perform some sort of analytics in line on that data or in batch, you're going to start to see that the value of the data that we've left on the server room floor over the last X amount of years is exponential, because now with these edge technologies, we can very seamlessly derive all the things that we need to be successful.
There's many use cases where edge is preferred, perfect for real-time applications. So this could be any sort of processing that occurs to inform some sort of mission-critical activity that's occurring in an environment. That could be as something as close to industrial control. That could be object detection for safety and security. Also, where security and data privacy are important, companies tend to not want to send that data away from their site, and edge might be the best choice for that.
IT professionals have realized that moving their computational power closer to the edge boosts performance and enhances reliability, all while reducing latency. This enables the kind of real-time delivery that is necessary for many industries today. Industries such as oil and gas, retail, and manufacturing. But these benefits don't come without a cost.
Cost around the equipment itself, the maintenance and the skill sets required to handle that. Or you could even look into, the differences between OpEx and CapEx with regards to leasing equipment versus buying into a supplementary cloud infrastructure.
This whole notion of edge as a service is going to be a really key topic, where I buy edge compute from a service provider, and you basically get the public cloud experience on-prem compared to very, very heavy IT lift historically when you're building your own traditional on-prem data centers.
Experts want industries who rely on or are looking for edge solutions to recognize edge isn't a replacement for the cloud, but merely a branch of the same tree.
Another case could be that your edge elements are completely running autonomously until they are able to get connection back to the cloud, so it runs regardless if it loses connectivity here and there. But maybe the cloud you leverage to train the AI models that you're deploying to run autonomously at the edge. So the cloud was still involved in that overall solution lifecycle, just not continuously. It really is important to kind of look at this as a kind of a symbiotic relationship between edge and cloud.
When you see companies that are actually taking advantage of IoT, they're the same companies that are effectively deploying edge. They go hand in hand. You cannot have one without the other successfully at scale. So we've seen people pilot. They've been able to run 1 or 2 use cases in the cloud for a handful of locations, but when they start looking to deploy that at all their factories globally or all their stores, that's when they realize this can't run in the cloud. It has to run at the edge. They've taken the first step. They're now using machine learning models to extract value from IoT. And because they were the first to do that, they're the first ones to start deploying edge. And they're the leaders. They're the pioneers that everyone else is going to have to catch up with.
Why is there this decentralization that's happening away from the cloud? And it's definitely not because the cloud is not doing its job. It's really an ability to really drive the proximity of data closer to data generation. So a good example would be during this pandemic that we've had, the cloud was a major resource that everyone relied on to be able to run their daily operations. So the cloud is not going to go anywhere.
As we look forward in the future, we believe that interoperability will continue to increase across edge and cloud, and that will lead to a lot more kinds of hybrid deployments where there's certain functions of an application occurring at the edge and other functions occurring in the cloud, depending on what the requirements of the specific functions are, as opposed to the applications as a whole. That will allow for more best-in-class deployments where you get the value of doing things on the edge that require that, and same thing within the cloud. And in that way, both optimizing costs and efficiencies and value and impact of those applications in doing so.
So we are seeing some redundancy built in where a lot more decisions are being made at the edge as the technology becomes more and more advanced, and then sending some data up to the cloud. It really depends on what you're trying to accomplish, but we now have 2 tools out there for us. The option to have both is extremely important, and we're seeing a lot of innovation when it comes to both cloud and edge computing.
Edge computing is expected to continue growing at a rapid pace. According to a study from Markets and Markets, the edge computing market size is expected to grow from $36.5 billion in 2021 to $87.3 billion by 2026, at a compound annual growth rate of 19% during the forecast period. The challenge for IT professionals moving forward will be to evaluate the strengths and the weaknesses of the edge and the cloud and make an informed decision that best meets their particular needs. One thing is clear, though: we're only on the precipice of growth for the edge. All right, folks, our last piece of content from the world of technology today comes from the Infinite IoT podcast with Matt Ackley. On this episode, Matt spoke to Harold Remmert from Digi International about the evolution of cellular networks. Here is a chunk of that interview.
Harold, welcome to the show.
Great to be here, Matt. Long time no see.
How's everything going in the world of Digi?
Well, it's going very well, actually. Just released our numbers yesterday, and it's exciting to see all the things we're working on.
I wanted to start off with asking you, what did the pivot into the 4G LTE provide us that maybe we didn't have access to or couldn't get value out of with the previous networks?
Yeah, when you look at the evolution, roughly every decade, we see a new cellular technology generation, or how people refer to it as Gs, so generations, with new capabilities for new use cases. So when you look back, 2G was introduced in the early 90s, and that was a great technology, provide the first digital voice and low-speed data experience. When you move on to 3G, that was launched in the early 2000s, that offered significantly faster speed, which became one of the success factors for smartphones, for example. Right, so being able to browse the internet, download music, stream video, and when you look back, the technology was there, and only after it was there, companies like Facebook, Twitter, and many other social media platforms, in combination with the smartphones, they really leveraged that technology, right? And, grew to a big success with that. This is also the era when we at Digi introduced our first cellular router. So this was in 2004, so quite a ways back. When we then look forward or look at the at 4G LTE, so this started in 2009. The initial focus was still on faster speeds, so kind of pushing that angle. But over the last decade, that technology has changed significantly. So LTE stands for long-term evolution, and so the continuous evolution of the technology generation towards the next. And what that brought us, and what was not possible before with previous generation technologies, was really to have one network that can scale from the very low end, with technologies like LTE-M and NB-IoT that are great for sensors, inexpensive trackers, battery-powered devices, right? So really optimized for that, and for a large number of devices as well. And then all the way to the high end, where LTE-defined technologies, leading to gigabit LTE, right, that can replace wired broadband. So all on the same network, and so that's really, one of the difference between 2G, 3G initially, right? So very focused, and then 4G really expanding that the number of use cases that you can get.
Was there greatly impacted infrastructure? Obviously, we have a scenario where you're changing out nodes and you're doing a number of different things on that front. I mean, was there a dramatic shift in the necessity to pivot kind of structurally from those technologies to to the next generation?
Yeah, absolutely. I mean, the base stations had to be replaced. There was a lot of RF front-end work as well, right? So new antennas had to be put up. New bands became available, so new spectrum, right? So that had to be serviced. And when you look at the network technology, the infrastructure, that really changed, started with 4G and really, pushed into 5G as well, where more of the functions that the network provides were compartmentalized, were containerized, and they're much easier to deploy. They can run on regular, data center grade hardware. You don't need to have specialized monolithic hardware anymore, right? So that really drives the economy of scale, makes these systems much easier to deploy, right? And easier to update. Sorry, go ahead.
Oh, I'm sorry about that, Harold. Didn't mean to cut you off on that, but I did want to ask. So the pivot then from 4G to 5G, most people, to the layman, we're just adding a number and putting it in front of G, and away we go. We just on to the next, right?
Yeah.
But there seems to be a dynamic shift as far as the capabilities when we talk about the spectrum of capabilities and the data analytics side of it, and the ability to specify where we want to pull data from. So when we pivot from that 4G LTE, which is going to be here for a little while longer, type of a deal, into this new frontier of 5G, what's the largest shift from what we were used to into this new frontier of 5G?
Yeah, good question. So 5G is not just faster internet. Here at Digi, we truly believe that it will transform the way we live, work, and play. So you get the faster speed, right? So now with 5G pushing multi-gigabit speeds, it is increasing the number of devices as well that the network can support. But also, the standards bodies have done some work to reduce latency for near real-time applications. And what that gives you is it gives you a massive amount of speed at a super low latency. And, when you take a phone, for example, right? So right now you have your applications loaded on the phone, right? With 4G, you can also stream, right? But oftentimes you still download. When you have a lot of this faster near real-time transportation link, and you have data centers that are also moving very much closer to the mobile edge, right? So this is where the whole notion of edge compute comes in. You can actually offload a lot of that to the edge, right? And when you need it, you can just pull that down again, right? So you can have conceivably phones that are very slim. They just know how to connect to the network, right? They have very little RAM and flash, right? And they just download the application whenever you need it, right? And then offloads it again. So it really changes the dynamics. You also then can do things, around machine learning and AI, where you, let's say, want to do some video analytics, right? And so that's usually a very heavy undertaking, because the video data is there, right? So you need to shove it to a central location normally, right? So you would do the analysis, and then you would send any results back. When you have this big low latency data pipe, you can really do that in the edge, and you can do that at a data center at the edge. So you really don't have to traverse the internet to get it to a central location, right? So you can do this locally. And of course, so we like to think about data as having a weight, right? So the more data you generate, the more heavy it gets, right? And the further it needs to transport, the more expensive it gets. So being able to do this processing, on site, in some cases on the device, but in many cases on the mobile edge, you really have this best of both worlds. And 5G is really some call it the wireless fiber, right? So being able to have that high speed, low latency connection for those kind of new applications.
And so obviously we're introducing the whole edge computing element to this, and there's the benefits of the AI integration, but the reality has seemed to have been that we had these great ideas about how we were going to utilize elements to drive 5G adoption, and it seems like it's a little bit slower launching for some of these use cases. Is there a reason behind the composition of the network, or some other element that maybe has led to a slower build with 5G so far?
Yeah, so it's interesting. There's two angles to this. So when you compare 5G to and the availability of the technology and the rollout to 4G LTE, 5G networks actually are being deployed and built out way faster than 4G was deployed. And also the number of devices that are available is significantly larger than it was with 4G. Now, there were some bumps in the road, and part of it is to get the network, obviously the infrastructure upgraded, right? So that's one. So it's just a function of capital investment, being able to upgrade all these nodes, right? So that requires personnel. And of course, during COVID, there was limits of what could be done. The rest of the technology needs to move along, right? So the chipsets, the modems have to evolve, right? So first generations are typically, have some challenges. They're not as optimized, right? They're not as, they might still be expensive, right? So those were some things that slowed it down. Also, with every new technology, and this is especially true for 5G, you need new spectrum, right? Spectrum is the lifeblood of wireless communication. And, in the US, the FCC has actually done a really good job in making the spectrum available quickly, or as quickly as they could. In some cases, it was new spectrum, like millimeter wave. Right? And so some players put their money on that. But it's a new technology, it's very high frequencies, and it's difficult to master, right? And it doesn't reach very far. So, you had to, put, if you wanted to light up a city, right? So you had to put an antenna on every on every intersection, basically, right? To light up. So you had millimeter wave maybe on a couple of blocks or in a stadium, right? So, but not further. There's some things happening where you have more inexpensive repeaters that are coming, that are showing up now, right? So where you can have maybe a repeater on every intersection, right? So it's much more cost effective, much more power effective. And so those are things that had to be developed first, right? After the standards became available for 5G to roll out. There were some other hiccups, things around, the FAA and FCC were not in sync relative to the C-band recently, right? So luckily that was settled quickly. And so that's actually a very exciting mid-band spectrum that will, give has good coverage characteristics and brings a lot of speed that customers will really see. So it moves you up from like the let's say the mid 50s, 60s, 70 megabits per second in a factor of 2, 3, 4, 5, right? So really pushing closer to that gigabit, or in some cases even beyond.
Be sure to subscribe to the Bytes on Bytes weekly newsletter from MarketScale to stay up to date with everything going on in the B2B tech world. Coming up next, David Kemp takes you into the Petri dish and gives you the latest in science and healthcare from MarketScale. David, take it away.